You'll remember when we played serious work of doing our 2-horse races, tossing coins. You might have found it took quite a time to toss coins, and depending on how good you are at tossing coins, it might have taken even longer. The other thing is when you toss real coins, of course, they are fair, they're 50-50. And we've talked a bit about independence and bias, but it's quite hard to play with that when you're just doing experiments like this. So what I'm going to do is show you a web tool that will enable you to play with coins, and you can have fair coins, you can have biased coins, and we can even have coins where when you toss one, the next one changes its likelihood depending on what's come before. So here's the page. I'll give you the URL for this in the web notes. It's actually a 1998 design page. It shows you what you could even do in 1998 with web things, but it wasn't so good then. But anyway, so you can see the race here, and you can see also the coin to toss, and I'm going to toss that coin, and I'm going to keep tossing coins, and you can see them pile up, and it's putting them into their lines for us. So lots and lots. We've got more heads at the moment. It looks like heads are going to win. Our head's going to get no tails. Oh, and a few heads. What's next? Another head. Oh, I thought heads were going to win there, and it's got there. Heads have won, and heads have won by. And now we can look. You could see the coins adding up at the bottom here, and also you could see the heads have won by 10-6. So it's put in this box, you can see the actual heads and tails, and it's keeping track of them, and this one it's telling you how many there was of each. However, if you look down the bottom, we could do that again. Should we do one more race like that? I'm going to hit lots so you can toss coins quite quickly and get through. Oh, this one's looking a bit closer, isn't it? And the tails have won this time. Okay, so that's what you've done by tossing ordinary coins, and these are just emulating ordinary coins. But now what we're going to do is manipulate the coins a bit. And down the bottom of the screen here, you can sort of see that there are a couple of things. There's a thing that says the probability of a head. So we can change the probability of heads. Let's change that down to something quite low. Like, let's make it 0.25. So this is now going to be a coin where it falls down tails 3 times as often as it falls down to heads. Okay, we've done that. Let's clear everything and restart and see what happens. So oops, if I can remember how to do this. So I did a restart to clear everything, and now let's start tossing coins again. And I got some heads, even though I changed it to the heads aren't likely, but well, yeah, quite a few heads. I always said these things were wheels and wires. These really are random. See, I'm not doing it. And then after a while, we'll do it again. Now, you can't tell much from one race, because actually some of our ones, when the coins were fair, you were getting this sort of thing. So let's do a few races, and again, I'll hit this quite rapidly multiple times. But you can see, oops, the tails are going to win again. We'll do a new race, and hitting it as many times as I can quite quickly, and the tails have won again. So you can see we can adjust it and have a biased coin, and we can play with biased coins. And I'm going to put the probability back to a half again, so it's going to be a 50-50 coin again. But underneath that figure that said probability of head or prob head, there's one that says correlation. And well, actually, strictly, this isn't 100% a correlation, but it's near enough. But it's about the likelihood that when you toss a head and it comes out ahead, is the next one more or less likely to come out the same? And a positive value here is going to make it more likely to be another head, or if it's been a tail, more likely to be another tail. And a negative value is going to do the opposite. We'll do a positive one first. So I'm going to give it quite a big-ish correlation. I think 0.8 tends to be quite a nice big-ish one here. So we're going to clear things again, restart, clear everything out completely, and set off. So I'm going to start tossing this coin. I said it's a fair coin, the first one. It's going to be 50-50. But after this, it's fallen tail, and it's now going to be more likely to be another tail. In fact, it was. Oh, but it can swap still. It's not that it can't be. But now, actually, if you notice, it keeps tossing more and more heads, because it's got quite a strong likelihood of staying the same. But it can swap, and that one swapped just on cue. That was very nice of it. I keep on tossing again. I get to the end, and we'll do another one like that. But I'll do some quite quickly. You can see it swapping over, then staying, but when it does swap, it stays often on the swapped one for a while. Okay, that's done. To get a sort of feel for that. Again, even that's a bit boring because we happen to go an awful lot. So to get a sort of a better sense of what it's like when you do really lots of coin tossing, I've got a second page which basically does this a lot quicker. So let's have a look on the second page. It's going to look very much the same. So here we are on the second page. Calls itself More Coin Tossing. I mean, really inventive naming going on here. We've got rid of the actual race, and in fact this isn't going to be a race as such. So the previous one was a straight race, but this one it's more like you've got a pile. I'm collecting some coins up. I'm not quite sure how many I've got, but let's do just counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what this one's going to do, it's going to say, I'm going to take 10 coins, I'm going to toss them one by one. I won't try and do that in the camera. And we'll see how many heads and tails we've got. So instead of going to the winning post, this is just going to do 10 coin tosses. So I forgot to set up, you can change the number of coin tosses. I've got to set up to 10, and it's going to do that 5 times. So it's going to toss 10 coins, then do that again, then do that again, do it again. So let's have a go. I'm going to press the coin here to start, and do 10 tosses 5 times. So there's the first 10, there's the second 10, there's the... It's a lot faster this, isn't it? Wow, we've done 50 coin tosses just like that. So you can sort of see that, and you can see at the bottom we can play with these properties. And in fact, this is defaulted to have a correlation. So I'm going to put it now to 0. So we're going to go for a straight fair coin, 50-50, no correlation between coin tosses. These are going to be independent coin tosses, and I'm going to make these numbers a little bit bigger. I'm going to go for 20 coin tosses at a time, and I will do 10 lots of that. So I'm going to do 20 coin tosses each time. So you'd expect on average to be 10 to 10, but of course it won't be, and we'll see that. So let's clear things and start tossing. And I can sit back and let the computer do all the coin tossing. How far is it through? It looks like it's about 8 or 9 through. Oh, no, it's finished. It's finished. 10 rows, that's right. So look at these 10 rows. Oh, actually, whoa, look at that. Exactly 100 of each. That's a fluke. It shouldn't be that good most of the time. I'm something wrong with my software. No, I'm sure it is working right. It just happens to be that this time it was 10 to 10. So the mean was 10 of each. And actually look at that standard deviation figure of 2. That's the amount of variability between these. So they're sort of 10 to 10, the coin tosses, but it goes up and down by a factor of about 2. So if we just I'll clear that and do it again. So, you know, this, hopefully we won't get a fluke and exactly get 100 to 100 this time. That was 200 coins we tossed entire. So tossing another 200 coins for us. Chunta, 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 chunta. And 200 coins later. Oh, this time our averages are not quite as good. They're sort of slightly off 10 to 10. So it's not too perfect, otherwise you'd think I was cheating. And the standard deviation is slightly different, that variability, because this is the variability we actually saw in the coin tossing. It's a theoretical one, it's what we actually saw. And it's a bit over 2 to 2.3. I'm pointing you to that variation because remember we've talked about the fact that non-independence can often increase variability. Actually, we'll see the opposite happen as well. So what we do now, remember that figure of around 2 and a bit-ish for that variability. And now what we're going to do is play with this correlation again. And we're going to keep the probability at being 0.5, but I'm going to make that correlation 0.8. So I make it positive. Clear everything, so we're starting from scratch. And let's go and toss. And now our coin is, as I said, when you toss it, if it comes up a head, more likely to come up a head next time. If it comes up a tail, more likely to come a tail next time. So it's a positive relationship between coin tosses. So let's throw it and see what happens. And yeah, we can see some long runs of tails there and some long runs of heads. So once it starts with a coin, it keeps with it. It's chuntering its way through. Wait a few minutes. Oh, it's finished. So it's come out, the averages, because it was still a fair coin. So sometimes you got long runs of tails, but sometimes you've got long runs of heads. So the average has come out about the same. But look at that standard deviation, that's measure of variability. And if you look down this, you see 0 to 20, 14 to 16, 20 to nothing. Some near the middle. It's not that it can never be near the middle. There's a 9 to 11 here, but a lot of extreme values. The variation is big. So the variation, if you just toss coins, was a sort of 2-ish, or so, so I'm guessing that was sort of like 8 to 12E type size is quite typical. But here, 7 points of y. So you're not, so things are a long way apart. It's going, so the variability has increased because now these are no longer independent, and you can see those long runs happening. Very occasionally, mostly when you run experiments, if there are non-independence effects, they're often there for this positive kind that makes one thing be a bit like the previous one. But sometimes it can be the opposite. So what I'm going to do is just clear this again, and we'll try a negative correlation. So what this means is that when you toss one coin, the next one is more likely to be the opposite. And let's see what happens when we run that. And chunt away, let it go. But you can already see it's doing a lot of alternations here. So if you can't see that in the video, we'll have some close-ups in notes that go with it. But here, this first one is going tail, head, tail, head, head, a double head, tail, tail, head, tail, head, tail, head, tail, head, tail, tail, head, tail, tail. But lots and lots of alternations. The overall average, again, coming out about 10 to 10, near enough if we run it again. But now look, the standard deviation's small. It's more like, said the way that if you toss 10 coins and they all came up heads, you'd expect the next one to be a tail to even out the world, World doesn't work like that with coin tosses. It'll just be a head or a tail 50-50. But this one's acting more like that. It's trying to sort of reverse what it did the last time. And that's actually reduced variability. As I said, you see that effect much less often than the one that grows the variability, where you get long runs of things, perhaps because of learning effects. But sometimes this happens as well. So I think from this you can, I've shown you, go and play yourself, get a feel for it, do this multiple times. Again, I've just shown you running this once, run it multiple times, put big numbers in there, try it with 100 rows, and just see the effects of size and the way that makes things change. And basically play and have fun with it.